but there are a lot of applications of exponential and logarithmic equations. One of those is compound interest. So we're going to go through a little bit of a derivation of that and look at an example. So first off, let's consider that we have some principal P invested at an annual rate R. If this interest is compounded n times per year for t years, and the amount in the account is given by this expression. The amount in the account A is equal to the principal times the quantity, 1 plus the annual rate over the number of times compounded, that raised to the number of times compounded times t years. So you can see that this is an exponential function with a base here of 1 plus the rate over the number of times compounded raised to the number of times compounded times the number of years. If we have continuous compounding, then the natural base e shows up. So we have the amount equals the principal times e raised to the RT power. There is no n in this case. We could consider this to be the n equals infinity case. Okay, so if you have a discrete number of times compounded per year, it's n. Otherwise, if it's continuous, we use this formula here. What does it mean to compound? Well, if we have an annual interest rate, let's just say 10%, and we compound more than, well, if we just have 10% for the year, what happens is the principal stays in the account for the whole year, and then at the end of the year, it's hit with the 10% interest. So you get the 10% interest at that point in time. If we compound, let's say we compound quarterly, so 4 times a year. What that does is it takes the yearly rate, the 10%, and splits it up into 4 parts. So 2.5% applied 4 times, equally spaced throughout the year. Now, that's better than having the 10% applied at the end. It's better because that after that first quarter, the principal gains the amount of 2.5%. And so it is now a larger amount of money that is then hit with the 2.5% that comes after that. It's applied 2 more times, and then at the end we'll have more than just applying the 10% once. Okay, so if we increase the number of times compounded, that will be better. It will have more return. Okay, let's use this equation in an example. So let's suppose we have $5,000 invested into an account that pays 6% per year for 10 years. We're going to find the interest find the amount in the account if the interest is compounded annually, quarterly, monthly, daily, and continuously. All right. Now, I've already calculated the values here, but let's set up one of these. Let's set up the quarterly case. So we have the amount that's going to be the principal, so 5,000 times 1 plus the rate, and we should always express the rate as a decimal. So 6% is 0.06. Divide by the number of times compounded, 4. Raised to the number of times compounded, 4, times the number of years, 10. So 4 times 10. All right, now this, if you plug this into your calculator, you might write that as 40. So to 4 times 10. We'll get this number rounded to 2 decimal places, rounded to the penny. All right, what changes as we change n? Well, this number here would change, and also this number would change. Okay, so you can see that as we increase the number of times compounded, we get more and more into the account. But moving up, so let's say moving from 1 to 4, we gain about, what's that? That's about $120 or so. Moving from 4 to 12, right, we gain only about $26. And moving from 12 to 365 gains only about $4. Going from the 365 to the continuous case is just a matter of a few pennies or a few cents. Right? How do we evaluate the continuous case? We'll use the A equals P equals RT formula, PERT like the shampoo. Amount equals principal, so 5,000, e to the rate 0.06 times time, which is 10. If we plug this into our calculator, it should get this value right here. Most common errors that I see are when you put this in the calculator, you want to make sure that all of this is in a grouping symbol, or you could just multiply the 10 times the 0.06. All right, so I suggest that you go ahead and use your calculator and see if the values match the values that I have here.